Okay, let's have a look at this vector, looking at vectors and trying to find vectors in Cartesian parametric form. And I'm going to take it back to something that we should know. Just looking at the line, if we were looking at the line connecting A and B, where A is the 0.13 and B is the 0.25, all we're looking for is something that starts at A and goes in the direction of AB. And how do we find the direction of AB? It is y2 minus y1 over x2 minus x1. And it's pretty much the same thing, and we're going to end up with some mx plus c. Now, when we're dealing with vectors, often we'll write this pretty much this in exactly the same form, but it'll end up being c plus lambda x. And c and x are slightly different, but pretty much that's what we're looking for. So let's look at it in terms of vectors. And again, we'll start with a nice simple 2 by 2. If we start with the point, or the vector 1, 3, and B is 2, 5, so we've got that. What we're looking for is the vector that is joining those. So it starts at 1, 3 and goes in the direction of BA. And what you've got to remember is that how do we find the direction BA? It's B minus A. So it's going to be the 2 minus 1, 5 minus 3. So 2 minus 1, 5 minus 3 is going to leave us with 1, 1, 2. And then we just, so in vector form, all it is here's the starting point at 1, 3 plus lambda times the direction that we're going. So the vector form is 1, 1, 3 plus lambda 1, 2. Now, I'm not sure if I'm saying that right, but that's the way I look at it. So if we want the x coordinate, or the x part of it, it's going to be the x part, or the top part is 1 plus lambda 1. The y is 3 plus 2 lambda. So y equals 3 plus 2 lambda. And we can make lambda the subject here. Lambda can be the subject by just taking the plus 1 over, and we get lambda equals x minus 1. Here we're going to get that it's going to be y minus 3 divided by 2. So what that gives us is two equations. So what we know now is that x minus 1 equals y minus 3 over 2. And we could do more with that because we've got two equations and two unknowns, so we could solve it and write different things. But when we've got three equations, we just leave it in this form. So I will leave that one in this form. Let's have a look at another example. We want to look at if it goes through these 2 points. So it goes through these 2 points. It starts all these two. It goes through 1, 2, 4. We're looking for the line that goes through 1, 2, 4 and 3, 12, 1. So the first thing what we're looking at is we let this be A and this be B. Let's look at the direction AB, or the vector AB. That's going to equal B minus A, which in this case is going to be 3, 12, 1 minus the 1, 2, 4, which is going to give us 2, 10, minus 3. So that's the sort of direction we're taking. And we know that it starts here at the point, or at A, which is 1, 2, 4. So what we get is we're looking at 1, 2, 4 plus some lambda 2, 10, minus 3. Okay. So again, we can write all this out in terms of x, y, and z. We might have that x equals 1 plus 2 lambda. We might have that y equals 2 plus 10 lambda. And we could have that z equals 4 plus minus 3 lambda. And again, that's one way to present them like that. We could also write them out in terms of lambda. So if we take the 1 over, it becomes x minus 1. Then we've got to divide by 2. That's what lambda is. Here we're going to have y minus 2. When we take this over, then we've got to divide by 10. That's what lambda is. And here we're going to have z minus 4. And then we've got to divide by minus 3. And that's what lambda is. So we could write it like this. Or we could know that these three things must be equal, so we could write it as x minus 1 over 2. We know that equals y minus 2 over 10, and we know that that also equals z minus 4 over minus 3, because they all equal lambda. So that's just another way of writing it. And the last one, we're looking at this. We want it through this point, or through this 2, 1, 3, parallel to 3, 4, 1. So pretty much that's already in our form. If we go back to thinking y equals mx plus c is pretty much the same as this y equals our starting point plus some scalar of the vector. So here's our starting point. So you've got 2, 1, 3 plus lambda outside of our 3, 4, 1. And then it's just a matter of working out what x is. X in this case is 2 plus 3 lambda. Y is 1 plus 4 lambda. And z is 3 plus lambda. And again, we can make lambda the subject of all of these fairly quickly. So here's one way to look at it. The other way, it becomes x minus 2 over 3 equals lambda. And we know that this becomes y minus 1 over 4 equals lambda. And this is just z minus 3 equals lambda. And again, we could write that out into x minus 2 over 3. We know that equals y minus 1 over 4. And we know that equals z minus 3. So they're the two ways we can write it out. Okay. That's the way I look at it. I hope I've used the right terminology. I probably haven't at times, but hopefully that makes sense to a few more people. Thanks.